Good afternoon all. This is Satish Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on linear time invariant discrete time systems, that is convolution sum. Empathy part, convolution in real life. First input signal, the initial signal enters these systems and then system block diagram, a visual representation of system components is created and then impulse response, a system response to a brief input is determined. Finally, we can get the output signal, the process signal emerges from the system. It is used in audio ecosystems, image blurring and sharpening, filtering noise in digital communication, heart rate signal smoothing. What are all the mind map nodes in convolution is nothing but input x of n, output y of n, and impulse response h of n. Next one, definition part of convolution sum. The convolution sum relates the input, output and unit sample response of the discrete time systems. Linear convolution is a very powerful technique used for analysis of linear time invariant discrete time systems. Y of n is equal to x of n into h of n. X of n is nothing but input signal, h of n is nothing but unit sample response, output signal is nothing but y of n. Next one, these are the methods of convolution sum. Four methods available to compute convolution sum: definition method, graphical method, tabulation method, and multiplication method. Definition method means direct application of the convolution formula, and then graphical method is visual representation of the convolution process. Tabulation method is organized table based approach for computation. Multiplication is method utilizing multiplication in the frequency domain. Next one, these are the steps to find the convolution sum. Four steps involved in computing convolution sum: folding, shifting, multiplication and summation. We can get the output result. Let capital M be the total number of samples of x of n and capital N be the total number of samples of h of n. Then the total number of samples in y of n will be m plus n minus 1. Next one, this is the ideate part representation of the convolution. First, we can get the given sequence as input sequence x of n, and also we can give the another input sequence as x input sequence as 1. Finally, we can, by using either definition method, a graphical method, multiplication method or tabulation method, for these two input sequences we can use any one method to find the output as convoluted sequence. X of 0 is equal to, that is nothing but y of 0 is equal to 1, y of 1 is equal to 1, y of 3 is equal to is nothing but 2. We can get like this as convoluted sequence. Up to total number of samples is nothing but 6 plus 6, this is nothing but 12. 12 minus 1, totally we can get it as 11 samples. That is nothing but x, y of 0 to y of 11. Next one, this is the another convolution sum example. Input sequence can be given with respect to as x of n. That is nothing but x of 0 is equal to 1, 1 is equal to 1, x of 2 is equal to 1, x of 3 is equal to 2, x of 4 is equal to 1, x of 5 is equal to 1. And also similarly for impulse sequence can be given h of 0 is equal to 1, h of 1 is equal to 1, h of 2 is equal to 2, h of 3 is equal to 1. For these two sequences, by using any one method, we can get it as your output as your linear convolution sequence. Y of n is equal to, that is y of 0 is equal to 1, y of 1 is equal to 2, y of 2 is equal to 4, 3 is equal to 6, y of 4 is equal to 6, y of 5 is equal to 7, y of 6 is equal to 4, y of 7 is equal to 4, y of 8 is equal to 2 or 1. This is the output sequence of the convolution sum. Next one, properties of convolution sum. It can be classified into three properties: commutative, associative, distributive. Commutative is defined as y of n is equal to x of n into h of n, or h of n into x of n. X of n can be multiplied with h of n, we can produce output as y of n. H of n multiplied with x of n, which can produce output as y of n. Next one, associative. X of n multiplied with h1 of n, again multiplied with h2 of n, we can get x of n into h1 of n into h2 of n. X of n multiplied with h1 of n, again multiplied with h2 of n, which can produce the output as y of n. Right hand side sequence x of n multiplied with h1 of n into h2 of n, which can produce output as y of n. Distribute to x of n multiplied with h1 of n added with x of n multiplied with h2 of n, which is equal to x of n into h1 of n plus h2 of n. X of n multiplied with h1 of n again multiplied with h2 of n. Going to add these two signals, we can produce the output as y of n. Right hand sided sequence x of n multiplied with h1 of n plus h2 of n, which can produce the output as y of n. Next one, this is the input and output transference. X of n, we can produce output as x dash of n. Again, that can be multiplied with h of n, which can produce output as y of n. By using same linear range, we can get the output y dash of n also. Next one, we can get the real-time simulation. First, graph of x of n and flipped as h of minus k. Summation points of each n. By using MATLAB or Python demo, we can get the output. Input signal that can be applied to convolution block, which can produce the output as convolution sum sequence. It is used in audio signal filtering, connection to DSP hardware. Next one, mind map, reflection and innovation. Compute y of n is equal to x of n into h of n for given sequence and identify the type of the system. Next, analyze the length of the output sequence. Next, application in AI, that is nothing but role in convolution neural networks. Next one, real-time signal processing in IoT devices. Right. Next one, digital audio enhancement. Next one, we can see the assessment. Define convolution sum. Convolution sum can be defined as y of n is equal to summation k is equal to minus infinite to plus infinite x of k into h of n minus k. How to calculate total number of samples in y of n? M plus n minus 1. List the methods involved to compute convolution sum. There are 4 methods involved to compute convolution sum: definition method, graphical method, tabulation method, and multiplication method. Y of n is equal to x of n into h of n. H of n into x of n is defined as commutative property. Mention the steps involved to compute linear convolution. There are 4 steps involved to compute linear convolution: folding, shifting, multiplication, summation. List the properties of convolution sum. They are divided into 3 properties: commutative, associative, and distributive. Thank you.